Views expressed are those of the individuals and do not necessarily reflect those of their employers. 3, 2, 1. Let's go! I'm the host of the PBE Podcast, Troy Tittlemier, co-host Andy Anderson. Man, you've made these shows fun and engaging from your perspective, and I'm going to definitely lean on you for this episode on Geomechanics with Integrity Insitu. Please introduce yourself, and let's talk with Cory.
You bet. Thank you very much for having me again. I appreciate it. It's been a lot of fun so far, and looking forward to this one as well. As mentioned, my name's Andy Anderson. I'm a petrophysicist with ConocoPhillips. I'm also here as the exhibits chair for the 67th Annual SPWLA Conference.
Nice. And as exhibit chair, how much geomechanics stuff did you see this year?
Actually, I saw quite a range. Yeah, definitely it's a part of a lot of what many people are speaking about. I mean, it's important to everyone, obviously. Wellbore security is a big deal. And so whether the companies were focused on multiple services, it seems to be a part of it regardless, right? It's always incorporated. So obviously there's many companies who are focused away from that, but whether it was coring, whether it was wireline tools, whether it was LWD, it seems to be coming back in from many different directions.
Nice. Well, let's dive in, Cory. Welcome to the show, sir.
Thank you very much, sir. Appreciate the opportunity to be here.
Yeah, likewise. I mean, you're a Media Hub sponsor this year for the 67th Annual SPWLA, so obviously a huge deal for us to be here, a huge deal for, I think, SPWLA. Everyone is definitely in appreciation for your support for this opportunity to capture the kind of the technical voices and the breakthroughs that are happening from our perspective during this show. You know, that's what we hope we're providing. That's our goal, right? Is you have so much going on in the technical talks, the poster sessions, and everyone's walking away with some form of new education, new information, some new data, new thoughts. And this gives us an opportunity to sit down and go, what'd you hear? What'd you like this morning, you heard something about Halliburton doing a similar talk.
Right.
You know, those like little things that just drop out, we get to capture those on the mics.
Absolutely. No, it's a valuable venue, obviously, but the overall concept of what you've done here, Troy, and bring those conversations into the same room and the table, the microphones, it's a fantastic product, and it does really get the job done because people are here to learn, people are here to network, people are here to spread the word and press some flesh, and it's an exciting opportunity. So thank you very much for allowing us to participate.
Awesome, man. Let's rock it back. Who is Cory Fehr?
Wow, Cory Fehr is a father of 4.
Whoa.
I'm a fellow who's from the flatlands of northern Saskatchewan here in Canada, up in Canada. My family were entrepreneurial from the get-go. My parents were both entrepreneurs who moved us to Calgary in the mid-'80s to pursue a better life and some dreams and goals that they had. And I grew up in that environment and saw them work their butts off for 20 years. They had a home cleaning business that did well, and they eventually sold that and got involved in a number of different opportunities that us kids kind of got dragged into. Honestly, some of my fondest childhood memories were being part of what they did to accomplish these goals. I remember literally folding rags, cleaning rags in the basement of our home on Friday nights with a bucket of Slurpees my dad would go pick up, and all of us kids would get thousands of cleaning rags dumped on the floor in front of us, and we'd fold them and they'd get put in the back in the bags for the staff to use on Monday or whatever it was. And as they went through their entrepreneurial life cycle, we'd have motivational tapes playing in the car, and we'd have posters on the wall of attitude and mindset.
No kidding. So your parents were strong, man.
They really planted that seed, and it's not that they understand oil and gas or geomechanics or anything like that, but any entrepreneur has got a different thing inside of them, and it can go from one field to the other, from decade to decade, and a lot of lifelong entrepreneurs change tacks throughout.
When you got into school, getting through undergrad and all these things, right, did you always have this entrepreneurial spirit because of your parents? You're always thinking of, like, there's got to be something new, there's got to be a different way to do something. Is that kind of the mindset you always had?
Well, in a sense, I've always understood cash flow and the finite amount of time we have on this world, and always had goals. And one of my major goals was essentially to control my time. And that's going to be by being self-employed, and even though when you're self-employed, you work way harder and way longer hours than anybody else, you do the things that you want to do with that time. It's not the same, obviously, as going to an organization that tells you this is what we need you to do, so go do that, and hopefully you fall in love with it.
Right.
You choose what you're going to do, and you do the things that you enjoy. But I started on the bottom in oil and gas in the mid '90s, working at Core Labs actually, and over the years that spread to different realms of responsibility and exposure to different parts of the industry, and the more I saw, the more I became curious and fascinated by it, and I really fell in love with geology. I fell in love with reservoir engineering and went to technical school for both of those, and eventually got into computer programming and project management. But the actual hands-on work involved on rig sites was a big part of where I kind of enjoyed being. I enjoyed the field life. I'm a hunter and a fisherman, and I love to camp and be out traveling and seeing new sites and trying new things, different places.
It's not exactly camping when you go to a drill rig.
It's a lot more glamorous on a drill rig than a lot of the campsites I've been in, trust me. But,
it's kind of crazy to say.
but throughout all of that, I did always have a side interest in a business, and whether I was directly managing or helping manage, I needed to make sure that I had cash flow that guaranteed my goals outside of a day-to-day job. And eventually, business number 4, actually, because I've been involved in multiple different types of businesses, when I saw the way that we collect geomechanical data and the shortcomings, the inefficiencies, the challenges that exist that really keep operators from gathering physical measurements, not only did I see an opportunity, but I was aware of a solution. So went from there to get to what we've done today.
Let's talk about the approach, geomechanics, like the history of geomechanics and the tools up until Integrity Insitu, physically measuring this thing. You're talking about dipole sonics are giving you kind of compression and shear, and you can try to start calculating based on that data where your SH max might be and what's frackable, what's not, or what's the history of geomechanics, Andy?
Well, I'm wondering just how involved you were maybe on the drill site with when it comes to formation integrity testing, if you had a background in that perhaps. I don't know if that exposure is what kicked this off, or you mentioned the lab. Was it some of the lab testing? Was there some geomechanical testing that you were already familiar with there that kind of shifted you in this direction, or what portions of geomechanics? There's a wide spectrum, like Troy mentioned. There's the wireline side, there's the drilling side, there's the lab side. So was it all of it together? Or is
Andy's a very logical thinker. One would think that because of my experience in the lab.
We got to take a quick break from the show and talk about our sponsors. What if your data actually worked for you? Upstream Plus, starting in accounting, built from over 16 years experience solving reporting challenges, reconciling complex oil and gas data, and turning fragmented information into clear, actionable insight. Because in this industry, the problem isn't a lack of data, it's the lack of clarity. Today, Upstream Plus is redefining what an LOS should be. A decision command center for operators, non-operators, mineral and royalty owners to protect assets, save time, improve decisions, and restore accountability down to the well level. Because in oil and gas, clarity isn't a luxury, it's power. Upstream Plus, see your operations clearly, decide with confidence.
Or because of my experience running deep mini fracs in coal bed methane in the early 2000s, that is where the geomechanical interest began, but it wasn't there. It was actually 10 years later when we're working on Caprock integrity studies for SAGD projects in the oil sands on the operator side. But it was when I became involved in the overall management of the data collection and what we do with it, how much it costs, what those physical processes look like. That's when I really began educating myself on geomechanics. Yeah. But when I worked at Core Labs, I literally, like I said, I started at the bottom of the totem pole. And just like folding rags, apparently I'm good at folding things, I was folding cardboard boxes. I took the inserts that go into core boxes, and I folded them, and I took the cutouts to make the box, and I folded it into the core box. I put the insert in, I put the lid on, and I'd label it. I did that 1 million times. And I got so good at folding these damn boxes, they said, hey, you should slab the core that goes in these boxes right on. Let me run the saw.
Let me run the saw. How about
and
that?
you put on all your wet gear and
PPE.
I to this day, I kid you not, I have clothes that still have bitumen stains up the sleeves from running that core slabbing saw with core samples from the oil sands. And once you do that enough times, they say, hey, you've succeeded. You've graduated from running that core saw. So now we're going to put you in the lab, and you're going to run Dean Stark's experiments and figure out saturations and porosities and all this kind of stuff.
Sheesh.
You're going to blow up some equipment and have fun along the way. And there were a bunch of teenagers running half of that lab. I couldn't believe it. It was amazing.
I couldn't believe it.
And I credit all of that to a very special guy named Dave Brooks.
Wow.
He was the manager of the lab, and he gave all these whippersnappers the opportunity to learn.
Go get it.
And get involved.
Yeah.
And it was great. And outside of, and then I was running that lab. I was the manager of the Dean Stark's operation. But later on, when I was working in coal bed methane, we'd go into the field to collect core samples, run all the degassing experiments, all the desorption experiments, go through all the different lab processes, and run isotherms and all this fun stuff. And that also entailed mini-frac testing to come up with some stress measurements. And those days were with a company called Coal Gas Technology. A bunch of great guys, Brad Vandenbush, Eric, what's Eric's last name? It'll come back to me, Eric Allen, and Greg Bell. And Greg was an American engineer. Greg was the American engineer, Eric was a British engineer, and Brad was a Canadian geologist. So these guys came together somehow, some consulting gig at one point in their lives, and then eventually decided to put together a service company. But they gave me a lot of opportunities to learn and grow, and that involved mini-frac testing in these coal seams. And we would take a horse trailer out to site with a gigantic, 2,000-liter drum in it with a sight tube and a tape measure behind it. And I would stand in this horse trailer while we used our pressure washer pump to create these downhole fracks. And I remember a talk one time that that Mr. Bell gave at whatever the Coal Bed Methane Society was at the time, because these acronyms change all the time with the smaller groups. And he was basically demonstrating how when you inject fluid into the ground, take a mop and turn it upside down and poke that stick into a bucket. When you inject fluid in the formation, you're poking a stick into a bucket. You don't know what that bucket sees. You don't know where that fluid goes, all these things. So anyway, even though we were running these tests and providing that data, he wasn't ignorant to the reality of what's happening downhole. So that was a fascinating experience and great exposure to the geomechanics world through those fellows.
That's fantastic. No, that's a great way to get into it, right from the grassroots.
So was it just like building up pressure and then seeing pressure release, and they just know that it broke through? That's all you can basically say? You don't know how or what broke kind of thing?
Right, because all you have for data is the pressure.
Got it.
You don't see the orientation. You don't know, unless you've got an offset well with a VSP going on and tilt meters at surface, depending on your depth, is that going to work? You don't know where that fluid went.
I got you.
Yeah, and there's a lot of other challenges that come with injecting fluid in the ground too.
Yeah, interesting. Okay, so you got first-hand experience of just kind of like, okay, so you can get fluid in it, you can break the rock down, right? But how's it doing it? How is that, at the end of the day, making a difference from an economic standpoint for the operator?
Sure.
Right? Great, you broke the rock. Is that helping me make more oil or gas, or what are we doing here?
Right.
Interesting. Okay, so then your next, so you get some physical experience there, obviously. Now you're kind of starting to really target and hone in on this geomechanics niche at this point. You're starting to really identify that there's something here. You got some interest in it. You're naturally passionate about this, and you just started pursuing people in that part of the industry, talking to more people in that part of the industry. How do you get from that to Integrity Insitu being the first of its kind and all this excitement?
Oh, it's a process, man. So when I witnessed the difficulties in the field on the rig of trying to core some of these materials, which may or may not work, and trying to preserve, transport, test the core, etc., run the separate process of a defit / mini frac, and then make sense of it all. A year later, when you get the data back from a lab, all the contracts that we put out to those vendors to perform that work, they came across my desk, and I read every word of every contract, and kind of always have, particularly starting then. You understand, and of course, being boots on the ground on the floor of the rig, you see exactly how the work is performed, and with the background that I had, I knew what was playing out and why and what it's for and how these things were accomplished. But when you wait a year to get the data, and it turns out that there's 2 samples in that report, and it costs nearly $1 million to run the mini fracs plus the core collection,
Analysis,
preservation, analysis, all the things that are involved with coming up with the full picture of that geomechanics puzzle, it's not a good taste in your mouth. And those 2 samples were from within 1 meter of each other, elevation-wise, in the same wellbore. So essentially you've done nothing except lose a year and learn how not to do it. So as I realized that this was a terribly inefficient process, I kind of got a little upset and talked to my bosses and said, hey, there's better ways to do this. Why don't we look at this and look at that? And I had a concept introduced to me by one of the consultants working with our company. He gave us a book about pressure meters. And I started to learn about pressure meters, and I found a geotechnical group in Eastern Canada that could provide the technology, but it's a different borehole size, and that one didn't have high pressure capacity, etc. And I couldn't get my boss to commit to trying it.
Yeah.
So that idea never left my head, and of course I knew about mini fracs, and I understood a lot about the lab processes and shear box testing for things like UCS cohesion and friction angle measurements with the more Coulomb stuff going on there. And I talked to a bunch of different PhDs in the industry and said, hey, what about this, what about that? If we took this idea and married it to that idea, would it be a suitable equivalent data set?
Wow.
And they all said, definitely.
You could do it.
Yep.
Wow.
And so that's kind of where it started. So that whole process of it percolating in my mind was probably 2-3 years long, and took a lot of research and whatnot. But
Connecting dots.
Yep. Eventually I committed and gave my notice at my day job and put together the beginnings of the foundations of Integrity Insitu.
So I'm curious to know approximately what time frame this was. I mean, what was going on in the industry at that time? Was there also a bit of a catalyst that came from industry in general? I mean, was geomechanics picking up? Was Caprock integrity becoming more important? Was wellbore failure starting to become more of an issue? Were wells being drilled longer or in different directions that happened to coincide with this, and a need for this data on a more rapid basis and a more regular basis?
Yeah, no, that's a great question, Andy. And everybody was in a pretty good mood. Oil was $150 the day that I left my job. But more importantly, about 5 years prior, there had been a very substantial Caprock failure incident in Northern Alberta, and it resulted in operator losing $1 billion resource. That was the.
Let's take a quick break from the show for a sponsor spotlight.
As an operator, you know that geomechanics play a massive role in the difference between a successful frac and a wasted stage. But are you still relying on uncalibrated models? The energy transition truly means moving from guesswork to precision, from generic outcome to optimized economics. Integrity Insitu delivers the world's most advanced geomechanical data set using their In-Situ tool, subsurface acquisition platform, and is the first and only company capable of physically measuring stress and strain at differential pressures over 12,000 psi without injecting a drop of fluid in both vertical and horizontal boreholes. Capture real-time physical calibrations for your closure pressure and stress magnitude when you need it and where you need it. Unlock your frac's potential and increase production with less effort. Visit integrityinsitu.com and catch our latest technical deep dive with them on PBE Podcast.
The purchase price for that land and asset, let alone the value of the 25 years production that would have come out of it. At the end of the day, Alberta was left with a crater the size of a football field, 30 feet deep.
Wow.
And that was a geomechanical, let's call it a misunderstanding. And the injection pressure for the steam chamber that was living underneath this caprock had been pressurized to the point where it did breach the caprock. and the entire thing exploded, sending trees through the air like missiles. Luckily, it was in the middle of nowhere, nobody was killed, but it could have very easily been a catastrophic loss of human life. So everybody in the oil sands was certainly aware of that, and really began sharpening their pencils on their geomechanical models and understanding what was actually going on. And this was a large company it happened to, so they weren't slouches. They had done their best, I guess, but apparently wasn't enough. And, that wasn't necessarily poking me in the ribs as to why we needed to take action, but it was when I was a client of the process that led to that I realized firsthand. I'm the kind of guy that I'm just stubborn, and I need to see things for myself a lot of times. And when I experienced that pain of that process myself, I realized, this is why people don't actually have these measurements. It's way too expensive, the process takes way too long, and it's terribly inefficient, because even if you had 100 samples come back in your report, we were still looking at a side-eye glance at the data saying, do we actually believe this? Because it's a disturbed piece of rock. And the lab then had to try to impose in-situ conditions, and that's fine. These processes have a ton of IQ points behind them.
Yeah.
I fully appreciate that. I'm not poo-pooing any of those people or those processes, but inherently you're taking a piece of disturbed rock from the ground and you're trying to replicate the in-situ conditions. So why not just test it in situ? So then we moved on, moving that lab process downhole. Yeah, thank you.
Man, slide the base of the microphone all the way to the edge of the table for you, just to keep capturing the audio the best we can here with Integrity Insitu at the 67th Annual SPWLA Symposium. It's fascinating. I just want to go back to this idea. Did they overcame the lithostatic load at surface and blew a chunk of the surface out of the ground?
Correct. I've got a lot of pictures, and there's reports online all about it.
What?
And this is one example, Troy. This is not the only time things like that have happened. There's videos from the 1970s near the airport in Fort McMurray, which is where the oil sands live in Northern Alberta. And this video from the 1970s shows a steam chamber releasing at surface.
Oh my God.
Because the Caprock failed. There's fractures throughout, and the minimum in-situ stress was overcome by this injection pressure, and pop goes the weasel.
My goodness. So we have, obviously, Andy, geomechanics. You understand all the details that he's kind of brushing over, broad stroke over these ways of trying to gather this information so that we can make best decisions on with what direction we want to go with the lateral, or how the reservoir's gonna frack. What do you have? What's your take so far on this?
Well, I mean, I'll definitely say that I'm not a geomechanics expert by any stretch of the imagination, but I mean, it's data that I incorporate, and these are analyses that I would use myself. And then, of course, I have been called upon in the past to be able to make some calculations in order to make these estimates for well planning, or to provide for modeling purposes, etc. And I mean, really, it is that data that you mentioned, this very long-term turnaround time data, which we rely on greatly, and a lot of that drilling information as well. I mean, we do, of course, incorporate all of the dynamic measurements being made in the wellbore from the sonic data, incorporating image logs, right, for stress orientations, looking at caliper data to be able to try to calibrate our geomechanical models too, so where we can say, okay, this is what we predict, and then what do we actually have to be able to say where we have the wellbore failure recorded on the calipers themselves, and then be able to fine-tune those stresses or those parameters that are needed in order to make those calculations. And I mean, yeah, it's a large undertaking for sure, and I know that there's a lot of good work that went into that. As you mentioned, there's a lot of very smart people who have developed a lot of these methods and the data and the analysis that goes into it. Yes, it has long-term turnaround time in the lab for sure.
Yeah.
The in-situ portion of it, I am actually quite new. Aside from reading up a little bit on your material, I was not familiar with the technology prior to this. So, we've talked about and we've run measurements where we've actually gone downhole, with a tool where we can actually do a mini frac, or obviously we have the analysis from the drilling tests. But but I'm not familiar with running the exact measurement that you made. But I've dealt with each of those individual pieces, I guess, and tried to put something together in my example, a 1D model. Wow. And it's critical. It's a difficult thing to do. We lack data quantity, of course, right? As you mentioned, you had your 1 or 2 samples happen to come from the reservoir. You're very lucky in many cases to be able to get these types of tests, whether they are, some sort of a pressure tool that's going to do a downhole mini frac, or whether it's a core sample, to be able to get them all the way through the reservoir, through all of the different rock types, through the caprock itself. I mean, it's very rare that we sample the caprock, right? Historically, I think it has been our data sets are generally concentrated in the reservoir. So, it's the idea of having a tool to be able to make the measurements in situ and be able to incorporate that data much more quickly is definitely intriguing.
Right. Sounds like a treat, man. With everything else, if you're running all your other wire lines and you got to make the call, you got to make the decision. So, let's set the stage on a project where you would deploy Integrity Insitu. Say it's 10,500 foot Permian Basin. You're going to go down to this kind of Wolfcamp A or something, right? And it's 150 feet of good-looking pay. They need to figure out which part of that 150 feet are we going to land this 6 3/4 bit and go lateral. Which direction are we going to go? And so you have the open hole. You've run your wire line, and now you're ready to go in with your tools. Sure. You have 2, right? You have the intelligent packer set up, and then you have the scratch test, and you have to run them separately.
Yeah, if you're on wireline, you want to be careful of how much weight you're putting on that cable. And when the entire tool is in one chunk, which is possible on pipe, then you'd be looking at about 500 pounds if the entire tool were bolted together. So on wireline, we do run the 2 functionalities separately just to make sure you're minimizing the weight that's on that cable. But what you would do essentially is you identify that target zone for the landing depth, for instance. And if the stress orientations and the stress magnitudes are the goal, then that would require the intelligent packer. If you're more interested in the UCS, which we're now starting to call ICS, in situ compressive strength versus unconfined compressive strength, cohesion and friction angle, that would be the shear head. So one is more for the strength properties, the other is more for the stress properties. But in this particular example, you would, whichever wireline provider is going to be on site, we would use an adapter to their cable head, and we'd bolt that on the top of the tool. You would run in, as you would with any other open hole tool, get to TD as quickly as possible, and basically the intelligent packer process is that of loading and unloading the wellbore wall with force, which is done through a membrane. Given that the foundational tool is a pressure meter, you've got essentially an instrumented packer on board. So you load the wellbore wall with force as you inflate this balloon, and you've got caliper arms inside of that balloon that are measuring displacements. The tool measures displacement and pressure, which in the rock translates to stress and strain. So a physical direct measurement, which can be used to calibrate the dynamic measurements coming off of a sonic, because you have to take those dynamic values to static all the time. And that's calibrated to what? It's calibrated to X value for a certain rock that they know the velocities through. It's not necessarily that rock at that depth at that location, but all of our tests are obviously the in-situ condition at that rock, that location. So the intelligent packer is going to load the wellbore wall with force and unload, and you run through this loading, unloading cycle many times.
What's the vertical displacement of that tool? Is it like just a few foot that it's doing that?
Yeah, the packer itself is 22 inches in height.
So 22-inch measurement against the wall of the rock. You start at the bottom of your target zone, do the stress test, you move it up 22 inches, do it again, move it up 22 inches, that kind of thing?
Yeah, whichever number of targets you want to hit, whether it's the underburden, the reservoir, a couple in the reservoir, a couple in the caprock, maybe something way up hole. Drillers, when they know that they can get it in situ without taking core, because core is at a premium. And it's generally going to come from the reservoir because that's where we make our money. But if you can't get to that reservoir, and if you can't keep that hole open, what's the point? So understanding the drilling conditions uphole is also a big deal. And obviously there's a lot of other types of projects these days that are deemed unconventional, that are forcing people to wrap their minds around these problems in new ways that, geomechanics is not new. It's always been there. It's just what's happening in the ground. But our understanding of it and why we need to understand it, that's the impetus has certainly changed in the past, call it 10, 20 years.
Could we back it up and just help me a little bit with the understanding of the technology?
Yep.
So we are not fracturing the rock.
We can fracture the rock.
Sorry, I said that incorrectly. No, we are not pumping fluid into
Correct.
the rock. We are inflating a packer against the rock.
Correct.
So we are taking it through to failure
Yep.
and actually fracturing it with this membrane.
You can, yes.
Okay.
Depends on the test design. It depends on the rock type.
Yep.
But I was talking to Troy earlier about a different offshoot of a pressure meter from 25 years ago that was essentially creating what's known as a sleeve frac. And we can create a sleeve frac using our tool, but our tool is instrumented with the 12-arm caliper, and yes, this is all patented for sure. But the difference between just using a packer to create this sleeve frac and what we do is that we actually measure the physical strain at the borehole wall while it's under pressure. And by watching that loading and unloading response, we see the elastic behavior of the rock and pull out shear modulus, which is easily translated to Young's modulus and all the wonderful terms. But if you push hard enough, you will create a tensile failure. And we demonstrated that in our lab and compared that to a mini frac failure a couple of years ago. And we also demonstrated that in a deep well in Oklahoma last summer in a 2% porosity limestone. So
A tensile fracture is going to be going parallel to maximum horizontal stress.
correct.
So you now have where that broke and which direction, how much pressure it took and where it broke and the direction it broke in.
Right, and when it comes to the pressure it took, people think of fracturing as a hydraulic process. It does not have to be. You can create a mechanical fracture, which is what the intelligent packer does. So the physical effect is the same. You create a crack in the rock, tensile failure, how it formed, why it formed. The rock doesn't care that a pressurized column of rubber pushed so hard that it had to break, or that a pressurized column of water pushed so hard that it had to break. The same physical effect is occurring, and the mechanical fracture has there's different pressures involved with that breakdown, what's happening at the fracture tip to create that growth, the fracture propagation. There's correlations between all of these things, and part of what our geomechanics engineers are tasked with now is kind of translating some of these industry understandings and the processes that go into those understandings into what we're doing, because it's not an apples to apples. You can't say this number is that number. We can say this is what physically happened at depth in your hole. We made a crack at this pressure, and this is what it means for your operation. And understanding the relationship between, say, the hydraulic process compared to the mechanical is part of the fun for sure.
Really? Okay.
Yeah. Oh, yeah.
And similarly, I guess, because you're measuring that pressure, I mean, as that relaxes or as it falls off, are you also able to capture what would be equivalent to the closure pressure or
Correct.
ultimately the extrapolation of the fracture gradient?
So what we're using is the fluid pressure within the tool that is required to create the crack and to allow that crack to close. And if you think about what's happening with a defit or mini frac, that is the same thing. You're seeing it inside of the crack versus at the well bore, but the system pressure, once you create that crack, you are connected physically, whether that interface is water or whether that interface is
The packer.
you are connected physically to that surface.
Yeah.
So it works.
Yeah, I could see that. I could see in theory. That's incredible. I was also thinking, like, how interesting would it be to go down to a zone, and you say you're going to go a vertical completion, swelling this packer up and basically breaking up that, if there are natural fractures already there, that's delivering this primary production. Well, now you're just busting it up even more, getting an understanding of what the rock is doing from a stress and strain standpoint. But then run your cement and casing, and now if that's your zone, you've just basically opened up more pathways of migration for your vertical frac. That's my brain went with it. If it's going to make these new tensile fractures in a zone that's full of hydrocarbon, now instead of your vertical completion going to the one natural crack that was there and it's all funneling into that crack and making that one crack bigger, which is probably what's happening in vertical completions, you have a way to break it all up and now frack it, and how many more pathways could potentially the stimulation get into and help with vertical completion and recovery, get that juice back.
Is that an intended application?
So I'm just going to summarize what I think I heard. And what I think I heard was permeability enhancement, near wellbore permeability enhancement.
Yeah.
I put a post on LinkedIn about a year ago to this exact subject, because in places like Pennsylvania, New York, you're not allowed to frack. They're allowed to put a certain amount of fluid in the ground, but it's very, very limited compared to a traditional frack job.
Okay.
So their challenges are, how are we going to do this when we only have 100,000 barrels to play with? And if we can create a fracture without needing to use any of that horsepower or fluid to overcome those initial breakdown requirements, then in theory you give that frac a head start on actually penetrating deeper and deeper in the reservoir.
Wow.
So it is absolutely an application.
Wow, that's interesting.
That is fantastic. That's very interesting. Yeah.
Thank you. And this is, we haven't done that with the tool, but it makes sense that it's possible.
You have me thinking about some of the places I've worked in the past where the regulatory requirements are fairly strict, and makes me think, well, maybe there is an alternative.
Well, absolutely.
Perhaps you could make an application in California or something like that where hydraulic fracturing is really not happening.
Right. And it's easy for me to say all these things, but don't take my word for it. We've written a dozen papers about this. We presented at URTEC, we presented at ARMA. Saudi Aramco is behind us on this current design of the tool, and Saudi Aramco are standing up in front of everybody at ARMA next month. And the conclusion slide on the presentation, first bullet point, In-Situ tool successfully validated. Stress measurements, reliable match, et cetera, et cetera. This isn't because I say so. This is, and the pressure meter technology has been around for more than 70, almost 80 years.
Wow.
Used by civil engineers, geotechnical engineers to measure stress, to measure shear modulus in situ on tunnel design, bridges, civil infrastructure. You can point a finger anywhere and you'll see it. Wow. And it's trusted for that purpose. So why the hell doesn't the patch do it? Well, now we can.
Let's take a quick break from the show for a sponsor spotlight.
As an operator, you know that geomechanics play a massive role in the difference between a successful frac and a wasted stage. But are you still relying on uncalibrated models? The energy transition truly means moving from guesswork to precision, from generic outcome to optimized economics. Integrity Insitu delivers the world's most advanced geomechanical dataset using their In-Situ tool, subsurface acquisition platform, and is the first and only company capable of physically measuring stress and strain at differential pressures over 12,000 psi without injecting a drop of fluid in both vertical and horizontal boreholes. Capture real-time physical calibrations for your closure pressure and stress magnitude when you need it and where you need it. Unlock your frac's potential and increase production with less effort. Visit integrityinsitu.com and catch our latest technical deep dive with them on PBE Podcast.
I think with innovation, you need someone that can really get behind you and give you some runway too, somebody that you can work consistently with on a bigger project than just a one-off well, right? I think that would be a huge breakthrough for Integrity Insitu.
It takes a village. It's the same thing as raising kids. When you're trying to raise a technology, it's a process that's very expensive, as you mentioned. You need as much access to testing opportunities as possible. We've drilled multiple wells on our own. I've drilled 4 wells on my own.
Whoa.
The one in Oklahoma and 3 in Canada.
Wow, just for a test site.
Just for a test site. And down here, you all have test sites that can be accessed by the public. In Oklahoma specifically, there were more at one point. And the big guys all have their own test sites that they do different things in.
Yeah.
But believe it or not, Alberta, which is essentially Texas North, does not have a publicly accessible test site. It's ridiculous. It's a laughing joke. But that's changing, apparently. We'll see when it happens. Obviously, people say a lot of things, and politicians will stand in front of a podium to say this is what we're going to do for the people and for the companies trying to help and make a difference.
Wow, that'd be cool.
It would be game-changing, but that's probably still a couple years away, 3 years away.
Yeah.
It was announced, I think it was last summer that was announced. But if you don't have one of the big guys closely knit into your process, it's going to be tough, and it's going to take a long time. And that's been part of our challenge, absolutely, since day one. We had small local investors involved from the beginning, and they've been incredibly supportive, and that number's grown and grown and grown as far as the number of people that are backing us up north. But we got incredibly fortunate in 2017 because Saudi Aramco did hear about our technology, the first prototype for shallow applications only, and they got involved and gave us a contract that we've been executing on for the past 5 years. Nice. And now we're planning our test wells in Saudi. I've been there a couple of times, and right now we're in the process of planning wells with Aramco.
Nice.
So even though they didn't bring a Brinks truck to my front door and say, do whatever you got to do, go spend the money, having their name involved obviously brings a lot of street cred, and
sure.
that brings people to the table for the initial conversation at least.
Consistency. You're showing that you've got years of a business relationship. You haven't been kicked out of the doors, right? You haven't been booted out. Like there's a lot of credibility there.
Thank you.
The breakthroughs. So how much publications are you guys planning to do over the next year or something? Are you guys just kind of just in the weeds, worry about publications later?
Well, it becomes more and more of your daily process as you make progress. We've got a paper being put out next month, like I said, at the ARMA conference in Tucson that Aramco is presenting on our behalf.
Nice.
And we've got one happening at the same time that I'll be presenting at ERTEC here in Houston. There's no shortage of opportunities to present what you're proud of. And SPWLA, great example. A lot of fantastic papers going on right now.
Yeah.
All of these take time, money, effort.
Yeah.
A lot of time and a lot of effort. And even if you're not the one authoring the paper, you'll be the one revising and helping make the edits and whatnot. And it takes a specific focused discipline to really put those papers together. Yeah. And right now there's so many rabbit holes to go down on any one day of the week that it's certainly not something we focus on, but it's absolutely an important part of gaining that traction and the exposure. Like Andy said, he had never heard of us, and most people haven't.
Right.
How would you have? We don't ever put up booths at conferences. We've done it in the past. We had one at the Gusau conference in Banff up in Alberta a couple of winters ago, but that was a special circumstance. We have submitted other papers in the past, but when you put these papers out, you're showing everybody what you did, and you have to be very, very careful about what you say, because people are going to research that paper, and they're going to apply it to what they're trying to do, and they're going to apply it, they're going to turn it against you as well. And you do want to obviously gain that academic buy-in and exposure and acceptance, but it's a very metered process, and you have to be strategic as to which ones, when, what you're going to talk about, what you're not going to talk about. How do you keep certain things proprietary? Because regardless of whether something's patented or not, that patent's worth what you're willing to spend in court defending it.
Wow.
And thankfully we have Aramco in our corner to help with that process should we need to. But it's not something I'm interested in inviting.
Yeah.
So you want to talk about it for sure, but you got to be cautious and measured with what you say.
Yeah.
Understandable. Yeah, definitely. I can appreciate that. I think that, as somebody who's attending the conferences and wants to hear about new technology and be able to bring something into the job that I do on a daily basis, it's always great to hear that. But I completely understand the balance that it is. And then, of course, the papers are great, but really what comes down to, I think, for most folks looking to incorporate a new technology is that track record. Right? Folks want to see that you've done the work. So I think that the fact that you have the test well data, the fact that you're getting out there and partnering with somebody else and proving it up, with a respectable partner, I think goes a long way for development. So that's fantastic to hear that.
Well said. Let's get into UCS and ICS. this is part of the scratch test that you do. Break that down. What are you after with that?
So UCS is all about the compressive strength of the material, and that's part of a couple different processes in a lab. Basically, you would take core up and you would crush it, and you would determine the compressive strength based on the outputs, and the sample is not confined by any specific pressure.
Let's take a quick break from this show and talk about our sponsors. What if your data actually worked for you? Upstream Plus was built with over 16 years in oil and gas accounting, solving reporting breakdowns and reconnecting financial and field reality. Today, Upstream Plus is redefining what an LOS should be, a true decision command center for operators, non-operators, mineral and royalty owners. One place to protect assets, save time, sharpen decisions, and restore accountability down to the well level. Because in this industry, clarity isn't a luxury, it's power. Upstream Plus, see your operations clearly, decide with confidence. Okay.
Whereas downhole, obviously, it is. So when we've gone through the overall process of comparing what this lab physic is compared to what we do downhole, a scratch test is comparable. There's also an indentation portion of what the shear head does that would be similar to, say, a cone penetrometer from the civil world. But the confining pressure of the downhole condition is the reality of what you're trying to deal with when you're drilling a rock or when you're trying to frack it, when you're installing casing, whatever you have to accomplish. But because we are using a different process to understand how much load that rock can take when you compress it by indenting that cone into it, the output that UCS name no longer applies because it isn't unconfined. And when you have somebody who was raised on shreddies their whole childhood, and you tell them they're going to start eating yogurt and granola, well, everything is still shreddies in their mind. So when you've got geomechanics PhDs looking at a data set, everything reverts to what they know about the process they used at their former employer's office, and that came up with UCS. And it's a difficult concept to think about a physical process that isn't the same as what you've been raised on. And you have to understand the physics, the foundational knowledge of what's actually happening to that material as you apply a load to it. You have to understand what's happening to those grains and what's happening with the failures. And is it a brittle response? Is it a ductile? Yada, yada, yada. What about when you've got different confining pressures acting upon it? And the questions never end.
Wow.
And that's life in the fast lane. That's what you're going to deal with. But at the end of the day, when you've got two numbers, if they are reasonably close and pass the sniff test of logic, you're in business. Yeah. And if the one number came from the ground, which is where you work, that's the one that I want. So it's not a real technical explanation on UCS or ICS, but changing that U to an I in our reports is probably going to happen. And it'll be communicated as a comparator to UCS. But when you explain the difference and why we call it ICS, and this is in situ compressive strength, it'll make sense.
Yeah, it does.
So for somebody who's going to take the data in and use it as an input to the calculations in order to build a 1D geomechanical model,
yeah.
I mean, because it is going to be a different number, right? It is confined in some way. So is there a correction that goes back to UCS so that I can put that number into my software or into my model? Or is it different equations that we're going to use that incorporate ICS?
Yeah, it could be either, Andy.
Okay.
And getting these numbers into the client's hands in a format that they're comfortable with and understand and can apply the way that they're used to applying other data sets is part of those next steps that we're taking right now. We've got a couple of conversations going on with some of the different modeling softwares to incorporate in-situ measurements and offer that to clients. And even if there wasn't a correlation factor between ICS and UCS, if you took the ICS to be UCS and ran with that. We'll see what that does to models, but so far so good. We've used our physical measurements in some Monte Carlo simulations. In that particular case, it was SH max, but the numbers all line up with what's expected. So it shouldn't be a great leap to make to see how those in situ values compare to the core
traditional UCS.
Yeah.
Okay,
Right.
very good.
You can also tractor this stuff down laterals, right?
No, we don't have any tractoring capability now, simply
Sorry,
because
I
of
used the wrong term. Tractoring is like actually how that's the term to actually get something out down the lateral. I'm sorry, I just meant like deployed.
deployed. Yeah.
Sorry.
Yeah, we can put the tool on pipe. We've got flex joints built into the body of the tool, and we can traverse dog legs as bad as 16 to 20 degrees.
So you get it out there on a drill bit, right?
After you drill.
Okay,
But we do have a behind the bit version on the sketchboard right now that
Wow.
we call GWD.
So right
That
now
might
you
change.
TD, you got a 2-mile lateral, you trip out, you get your technology on that drill pipe, and you drive it all the way back to TD.
Correct.
And then you can start running measurements down a lateral and then trip out.
Yes, sir.
Wow. You know, Oxy, I think it was Tamar opening remarks. She said that Oxy's drilling 500 wells this year in the
Nice.
Permian. Can you imagine
Mm-hmm.
getting the in situ stress on this lateral and 300 feet away or 600 feet away, you know, depending on spacing, and you're now getting in situ stresses, and you're just connecting these dots of how SH max is rotating and how it's in between faults and fractures of the seismic. I mean, it just seems like such a fascinating opportunity to just, I don't know. I mean, of course, we're trying to also correlate it to why. Why is it going to help me make more oil? Is it going to help? And that's a whole nother that's a whole nother rabbit hole. Try to go down. Okay, let's assume you do get that data. You know, how is it going to make you more hydrocarbons at the end of the day?
I wish you were the one making decisions at Oxy, Troy. I really do. We have run simulations that show what happens to horizontal production if you used our tool in the theoretical application of collecting stress and strength data along the length of the horizontal. Maybe it's 10 stations, maybe it's 5, maybe it's 25, don't know. It depends on how long you want to sit there with that rig holding onto the tool. Mm-hmm. But what we showed is that by applying our measurements, you would see where you have the strong or the weaker rock. You would see where the stress field changes as far as the magnitudes and potentially orientations. And then you could change the locations of those perf clusters. And if you take 40 clusters down to 30, but they're in the right spot, now what happens? You hit the sweet spot where your frac will propagate. You maximize that SRV.
Stimulated rock volume.
Exactly. And now you actually bring in more hydrocarbons, making you more money with fewer stages. Maybe you pump the same amount of sand and water through those fewer stages, maybe not. So you could potentially save water by reducing the number of stages. But knowing where to put them is the key. That's the crux of the problem. Where do you put these damn stages?
Yeah.
Well, we can show you that by taking the measurements along the horizontal. Now, another factor that you're going to love in that output, beyond seeing 23% more gas, and again, it's just a simulation. We all know about models. But the frac gets bigger in those stages that exist, that remain. Now, when the frac gets bigger, the drainage area increases. You move the next well by 500 meters because you don't want to have a collision. That frac gets bigger. You move the next well 500 meters. By the time you get to the edge of the pad, you drop a $10 million drill. You no longer need the same number of wells to drain that particular
SRV.
area. The same volume with less wells. That's efficiency. That's all it is, more with less. That's the meaning of efficiency, more with less. So by getting, number one, you make more money because you get higher production. Number two, you drain a larger area. Number three, you save by eliminating the odd well.
Interesting. Glad I asked that question. You've dove down that rabbit hole. And that's a good one, man.
Yep.
That's be something it's an interesting like sidebar, like little podcast we could do where you can show us how you simulated it and these calculations that everyone uses in industry with the data that it is, but now yours is coming from a different approach in ICS and how you convert that to UCS and still make these calculations and try to make sense of all this. That's like a technical little side show we can do down the road maybe and see that stuff in real time, watch you on the computer, running these things and talking to the guys on how you make those calculations and where the assumptions are.
When this project goes that you and I are doing right now, you're going to see some stuff that you've never seen before, and you're going to see an 8-panel real-time drilling center display in the logging shack, and this is innovation, man.
Right on.
Sounds exciting.
Thank you. It is exciting. It's game changing, and obviously it's not a silver bullet. There is no silver bullet, and there will never be an end to the questions. There will never be an end to the papers written about the theories, and that's fine. That's good. That's what you want.
Hell yeah!
But
gets me fired up.
The way that we do this now, there's room to grow. Let's put it that way.
Yeah, man. Andy, what do you got? Any final words on this?
I mean, it sounds like a bright future. I'm really excited to see where this goes. I'll definitely be keeping an eye on something that I wasn't keeping an eye on before, which is, I think, exactly why I want to come to these conferences and to hear from folks like yourself. I think on a personal note and perhaps on an SPWLA note, I'll echo what Troy had said at the very beginning of this conversation, is that, being a representative of the SPWLA, I'm so thankful for your sponsorship to be able to bring the PBE podcast in here for us, because this is a great way to start getting more technology out there and into a greater audience using a different medium. And I'm very thankful for that. I think it's looking really positive. So thank you for joining Troy and being with us.
Well, it's my pleasure. Thank you very much for the opportunity. It's not something that I do every day, but always open to trying new things and having new conversations. And the people are a massive motivator behind all this as well.
I was just about to ask, what's the motivation for you? What really keeps you going? And like a quote that you have that you just wake up with, like, what is it?
Oh man, that's a good question. If there was one, probably never give up. Never give up. And if it's to be, it's up to me. And that's not to say you're the only one capable. It means you have to do your job. You have to be the one to do your things. You have to be the one to make it happen in your life, whether it's getting to the gym, getting to the range, whatever you got to do it. Don't rely or wait for someone else to push you to make it happen. If you need to do something or want to do something, then do it. There's just no way around that. If something's going to happen for you, you're going to be the one to do it. But I had a life-changing event in 2015, and I nearly lost my life. And that taught me a lot of things, but one of them was that every day above ground is a good day. That's probably the one that I think about the most. Every day above ground is a good day. You don't know when it's your time. You do not have any control over when that bus is going to go by and you weren't paying attention, especially nowadays when we're all looking at our phones. But it also taught me a lot about fear and the power that fear has over us. You ask about why hasn't the industry done things like this? Well, part of that, you work for an operator, well, you tell me, why haven't you tried these new things? It's fear. It's fear of the unknown. It's fear of failure. And that holds all of us back every single moment of our lives if you let it. It's there. And when it gets its clutches on you, you can't make a decision. You will not roll the dice. You will not take a chance. You will not reach out to that family member you're feeling jilted by to have a conversation. You'll not try something new. It's hard. We're humans. We're stupid. We're flawed as hell. We got egos.
Yeah.
And we think we're a big deal, and we think we're smart, and we think we know it all.
Yeah.
We don't know anything about anything. And that's the only thing that I do know, is how dumb I am. That's the only thing I know. But
Humble, man. Humble is a good thing. Yeah, you got to have humility. You got to be humble. Yeah.
You got to be humble. And when it comes to that fear, when you go through enough or a certain type of trauma and you come out the other side because you face that fear and you know what danger is, you know what it actually means to your life, this type of stuff. You know, I went to Saudi Arabia a couple of times. I went to Norway. When I first started coming to Houston, I didn't know anybody, and I came here and cold called. Oh, that's hard. When I started this business, guys, I would literally go to the washroom before the meeting, and I would beat my chest like a gorilla to change my physical state of being to allow myself to speak to a room of people that did not want to hear what you had to say. Because that's just people. People aren't necessarily there for your benefit when you're trying to introduce a concept, change the way they do something, jeopardize their bonus. All of these things, there's a lot of daggers flying constantly, and that's okay. That's normal. But in the beginning, it was hard to face those crowds. And dealing with that fear is just part of what you got to do. You got to get over it. You got to get over yourself and your ego, and you got to do whatever it takes to succeed, because there's a lot of people counting on you, and nothing will change if you don't make it change. So anyway, that's a long-winded answer to your question, but I think that every day above ground is a good day for sure. Right. Let's count our blessings, and don't let fear dictate your decisions.
Man.
Great advice.
Yeah, right? Get me charged up. I feel like I need to go to the gym now.
Well, there's probably a couple in the hotel here.
Oh, yeah. There's no shortage of opportunities for me to work out. I just would think of 100 other things I'd like to do instead. It's my issue. Man, thank you again so much for your time. Thank you for your persistence and your commitment to geomechanics and breaking through with a new way of trying these things and helping operators better understand the fractures, which is providing the primary production, which is the tall part of the curve and in the decline curve, right? We need that good upfront production, level out that decline curve as fast as we can. The Thymar was talking about it in the show. She said, or in that opening remarks, is that, you know, we got to stay at least as good as we are, if not get better. There's no way we can get worse, right? We have to sustain what we have or get better. That's the only options. And this show echoed that, man. That's exactly what you're doing, and I appreciate it. Honored to spend time with you.
Oh, I appreciate you, brother. Thank you very much, and you're more than welcome. And reach out anytime to talk. I'd happy to talk about all this day or night.
So IntegrityInsitu.com.
Correct.
Cory Fehr on LinkedIn.
Yep.
You got a cell phone, email address, anything you want to drop?
Sure, yeah. My cell phone number is all over the place. It's 403-923-2908. And my email address is Charlie Foxtrot Echo Hotel Romeo C Fehr at integrityinsitu.com. Integrity, INTEGRITY, INSITU, INSITU.com.
There we go. Thank you, sir.
You're welcome. Thank you very much.
Nice to meet you. Thank you very much.
Likewise. Thank you, Andy.
As an operator, you know that geomechanics play a massive role in the difference between a successful frac and a wasted stage. But are you still relying on uncalibrated models? The energy transition truly means moving from guesswork to precision, from generic outcome to optimized economics. Integrity Insitu delivers the world's most advanced geomechanical dataset using their In-Situ tool, subsurface acquisition platform, and is the first and only company capable of physically measuring stress and strain at differential pressures over 12,000 psi without injecting a drop of fluid in both vertical and horizontal boreholes. Capture real-time physical calibrations for your closure pressure and stress magnitude when you need it and where you need it. Unlock your frac's potential and increase production with less effort. Visit integrityinsitu.com and catch our latest technical deep dive with them on PBE Podcast.
What if your data actually worked for you? Upstream Plus was built with over 16 years in oil and gas accounting, solving reporting breakdowns and reconnecting financial and field reality. Today, Upstream Plus is redefining what an LOS should be. A true decision command center for operators, non-operators, mineral and royalty owners. One place to protect assets, save time, sharpen decisions, and restore accountability down to the well level. Because in this industry, clarity isn't a luxury, it's power. Upstream Plus, see your operations clearly, decide with confidence.